Hello everyone, in previous videos I talked about how to download and customize MPLAB IDE, and in this video I'll talk about some notes before we get started with PIC microcontrollers. This is an optional video, but I recommend you hear the points I'm about to make if you are an actual absolute beginner. You can skip to any points in the video using the video slider or timestamps in the description below, so let's get started. In my videos, I won't go into too much detail about how electronics work since that would need its own series, so I'll assume that you know at least some basics. And if you don't, you can just use the same connections as mine. I'll still explain things, but obviously I won't be explaining things like basic calculations or volts or currents and etc. Which brings me to my first point. If you know nothing about electronics and trying to get started with microcontrollers, well, even though you can, I suggest otherwise. Without knowing basic electronics, it would be a waste of time, since you use microcontrollers to control those said electronics. What is the point of trying to learn how to control something without knowing what that thing is? Also, those said basic electronics are the core parts that make the microcontrollers work, so not knowing them will really hinder you. I heavily suggest learning electronics first. My suggestion is to buy one of those electronic starter kits for cheap and learn the basic components as well as the basic terms and calculations. You don't need to be an expert at all, of course, since most of the time you can get away with using pre-made modules like breakout boards, like the ones made for Arduino. I don't plan to make basic electronics tutorials, well, at least yet. But don't worry, there are plenty good tutorial videos out there since this is a very common and basic topic. I just said Arduino, which also brings me to my next topic, Arduino. For those who don't know and somehow managed to find these videos, Arduino is a very popular microcontroller breakout board. You might ask, what is a breakout board? A breakout board means a PCB that's mostly designed around a chip and has all the other required components needed by that chip. As I was saying, Arduino is also technically a breakout board, designed around a microcontroller. But Arduino is more like an environment than just a breakout board. There are multiple Arduino boards with different sizes and amount of connections. They also have their own dedicated IDE, which has a very clear syntax that is very beginner friendly. The Arduino community is huge, and there are tutorials for everything you can imagine, as well as pre-written codes and libraries, which is just a collection of codes, to just copy and use. That sounds amazing, right? Why even bother with all these complicated methods and codes and programmers and everything? Let's just all use Arduino. Well, other than being beginner friendly, Arduino doesn't really have anything going for it. In fact, if you said that you know how to use Arduino in a job interview, I doubt anyone would be too impressed. Not that it's not a good thing, it also means that you're interested, so do mention it in an interview. But don't forget that there's always a trade-off for simplification. The fact that the syntax is simple and codes are beginner friendly mean they are also slow to execute. The code has to account for every type of situation and the person that will make use of them, so they have to be generalized. That, most of the time, takes a lot of extra code. Something like this is especially bad for microcontrollers, since they have very little resources to begin with. That's kind of their whole point. Not to mention, they are very bulky since their breakout board has all sorts of electronics and connections tailored towards any and all users and use cases. Even just the programming USB port for the Arduino is times and times bigger than the actual chip that is doing everything. Being small is another big point for microcontrollers, it's kind of in their name. Arduino boards are also way more expensive than just buying the microcontrollers, on top of the fact that they use very old chips. They are just slow, power hungry, limited in their features and modules compared to what you find on the market today, especially for the newer microcontrollers on the market. But does that mean Arduino is just useless? Of course not. They are great for testing the capabilities of chips that use protocol communications to set and change their parameters. They are great for prototyping, giving their ease of use and how fast you can code them. They have immense library supports for every chip out there, so you don't need to read through hundreds of pages of datasheet just to test a chip. For simpler projects, you don't even need to know anything about microcontrollers or electronics. You can just follow a tutorial, copy its code and diagrams, and you're done. They are versatile, and most importantly, they are very beginner friendly. My last 2 points bring me back to my original point. If you know nothing about microcontrollers or what they do at all, I suggest you stop this series and buy yourself an Arduino Uno. Follow a couple of tutorials and make simple projects. You won't learn too much about how microcontrollers work under the hood, but at least you'll come into these series knowing the basics. It is also good for learning how to digitally control basic electronic components and the use cases for microcontrollers. It is of course not a must. I learned about Arduino after knowing how to code microcontrollers through datasheets, so it is possible to skip it, but personally I wish I did it the other way around. I realized that I've never really talked about microcontrollers. What actually is a microcontroller? Well, A microcontroller, on simpler terms, is just a very low power computer. Much like a computer, a microcontroller has a CPU, RAM, and flash memory, which would be the equivalent of a hard drive or an SSD on a computer. It's just that every component is much low power and limited. You may think that, but a microcontroller doesn't have a GPU. Well, you don't actually need a GPU for a PC. CPUs can also handle graphical information. It's just that nowadays there are many graphically intensive applications, or programs that need parallel calculations, and GPUs are designed particularly for these tasks, and handle them instead of the CPU. So these applications don't just drown the CPU. Not that the CPU couldn't do those tasks. In fact, you can easily make screens work using microcontrollers. It's just that they would be really slow, since they're not designed for nor fast enough for that. A small low-power computer like microcontrollers are perfect for reading sensors, using their data to make calculations and decisions, to control a variety of things like motors or switches, or to simply handle sets of protocols like TCP/IP used for Internet of Things, also known as IoT applications. These are of course only a fraction of the examples for microcontrollers. Microcontrollers typically have sets of modules inside of them for these tasks, aside from the CPU or memory, directly embedded in their silicon, which also sets them apart from the typical computer, such as timers for precise interval generation, common protocols like UART, SPI, I2C, USB, or CAN, analog to digital converters, or even digital to analog converters, EEPROM for permanent data storage, or PWM modules for power manipulation, and many more. These peripherals further support the microcontroller's main purpose, which is to make decisions and calculations, and manipulate circuitry. Some people, especially those who are migrating from Arduino to discrete microcontrollers, may have the question, how do you choose the microcontroller for your project? Well, it's very simple. Choose the cheapest microcontroller that you are capable of coding that can get the job done. That pretty much explains it. Main choosing factors are going to be price, connection count, peripheral set, and speed. Aside from price, you need a microcontroller that has enough peripherals and connections to get the job done. If you look up PIC microcontrollers, you'll see that they are named in a very confusing manner for a newcomer, like PIC 18F46K22. Let me break the naming down for you. The main three groups are 8-bit, 16-bit, and 32-bit microcontrollers. If you don't know what a bit means, 1 bit represents a single 0 or 1, and 8, 16, or 32-bit just represents the chip's register sizes. Registers are just block of storage that you can write 0 or 1 to and change the behavior of the microcontroller or make calculations. The more bits the microcontroller is able to move around at a time at the same speed, the faster the calculations are in general. So in general, 32-bit microcontrollers are more powerful than 16-bit, while 16-bit are more powerful than 8-bit, which also of course affect their price respectively. So don't just go out buying only 32-bit microcontrollers, especially if you are just learning, just stick to 8-bit microcontrollers for now. Once you know how to read datasheets and understand 8-bit microcontrollers, migrating to 16 or 32-bit is easy. 32-bit PIC microcontrollers name typically start with PIC 32, while 16-bit PIC microcontrollers name typically start with PIC 24. Why? Don't ask me. There are also microcontrollers that has their name start with DSPIC. There are also 16-bit microcontrollers that have specialized DSP engine for faster calculations and signal processing, but don't worry about them for now. Because I'm only going to cover 8-bit microcontrollers, let's dive deeper into its categories. 8-bit microcontrollers names typically start with PIC 12, PIC 16, or PIC 18. PIC 12 are old PIC series that has low number of connections and are slow. Most of the time you won't be using them. PIC 16 series are also old and are usually slow and expensive. There's an enhanced series for PIC 16 which has their names start with PIC 16 F1. They are in general newer and better. PIC 18 is also an old series, but there are relatively newer chips out there that outperform the rest. At the end of the day, you need to check their datasheets and choose the one you need. Before ending this part, I want to note something. Most of the time, 8-bit microcontrollers don't make sense. You can pay just a bit more or sometimes nothing to get a better 16 or 32-bit counterpart for the given 8-bit microcontroller. So I suggest migrating to them after these tutorials if you are confident. The way to program and use them will still be the same as 8-bit microcontrollers. That's why I said that it is relatively easy to migrate as long as you understand the working principle of microcontrollers and how to read their datasheets. I will still use 8-bit microcontrollers in these series, since the smaller register sizes make them a lot easier to learn for a beginner. I mean, if you can migrate to any microcontroller after learning how to properly code one, wouldn't it make sense to learn the easier one first? There's one more thing I want to talk about. In the previous video, I said that I will be using C language. If you've never coded in C, I suggest you take a course or a tutorial for it. I will explain the basics in a future video, but I won't go into too much detail about it. That would need its own series. And honestly, because C is the conventional starting language for beginners, there are really good tutorials and videos online for them. Me making another series would just not make sense. I will try to explain each line of code in detail. At least that's the plan. But I just can't explain C language syntax every step along the way. And the more videos I make and the more I code and explain everything, the more I'll assume that you get the point, and start explaining less about C language, since the code should start making sense to you after a while, and explaining the same things each and every video would just not be productive. And jumping into a coding language you have never seen, on top of trying to learn the terms for microcontrollers, will just not be a fun time. And that's the end of the video, and thank you for watching. If you liked the video, you can always leave a like and subscribe. It's always appreciated, and I'll see you in the next video.